A college has scholarship fund that pays money twice a year. Scholarship will pay out 500 at the end of 6 months and another 500 at the end of 1 year. Every year thereafter, the two semi-annual payments will be increased by 10. For example, in year 2, both payments will be 510. In year 3, both payments will be 520. Scholarship fund earns interest at annual effective 7.5%. Calculate the fund balance needed today to provide this scholarship indefinitely. So we see that this is not quite our regular arithmetic perpetuity, because there are two different streams running around. We don't have an increment in every payment. So two payments remain the same in a year, then the next two payments get increased to the same amount and so on. So what we need to do is we first list out to get the idea of when the payments are occurring. So we see that if we take the time in years, then the first payment is happening at time 0.5, because the first payment is happening in 6 months, which is half a year, and that payment is 500. Similarly, the second payment in the first year, which happens at the end of the year at time 1, is also 500. And then in year 2, both payments are 510. So we have 510 at time 1.5 and then 510 at time 2. And then similarly, in the next year, both payments get increased by 10 again. So it's 520 at time 2.5 and 520 at time 3, and so on. So we can break it up into odd payments and even payments. So if we first consider the odd payments, they start at time 0.5, because the first odd payment is the first payment, and the second odd payment is the third payment. So the odd payments start at time 0.5, and they actually increase. Every odd payment is 10 more than the previous. So the first odd payment is 500. The second odd payment is 510. The third odd payment is 520, and so on. And another thing to note is that the odd payments happen at 1 year intervals. So we can use the annual effective interest rate for those. And now they start at time 0.5. So it's convenient to first use the arithmetic perpetuity due formula, so that we get their value at 0.5, and then we can pull it back to time 0. We know that the perpetuity due formula gives the present value at the time of the first payment. So the first odd payment is happening at time 0.5. So if we use the 98.4 formula, which is for perpetuity due, we get their value, the value of the odd payments at the time of the first payment, that is at time 0.5. The formula is P over I plus Q over I squared times 1 plus I. And then we can see here that the odd payments have the first payment as 500 and the common difference as 10, 500, 510, 520, and so on. So P is 500 and Q is 10, and the interest rate was given to be 7.5%. So substituting these, we get the value of the odd payments at time 0.5 to be 9077.78, and we need their present value, so we pull this value through half a year. So you multiply it by 1 plus I power negative 0.5, and that gives us 8755.4. And now we can treat the even payments as a perpetuity immediate. That would be convenient, because the first even payment is happening at time 1, second is happening at time 2, third is happening at time 3. So these are annual payments. And if the first payment happens at time 1 and we use the perpetuity immediate formula, then we know that that will give us the value 1 period before the first payment, that is directly at time 0. So we won't need any further pulling back if we use the perpetuity immediate formula on the even payments, arithmetic perpetuity immediate formula. So that is P over I plus Q over I square. And again, for the even payments, the first of them is 500 and the common difference is 10. See, the first even payment is 500 and then the common difference is 10, because they're 500, 510, 520. And we get 8444.4 as the present value of the even payments. and we were to calculate the overall fund that we need right now to get this scholarship, which will be the present value of the two streams combined. So we add up the present value of the odd stream with the present value of the even stream, 8755.4 plus 8444.4. That gives us 17,200. That's choice E.